Okay, so this is the drill for today, so hopefully you've had time to work these problems out. You were asked to simplify. So when you simplify, that's not going to give you a decimal answer, that's going to give you an exact value answer. All of these are square roots, so you're breaking them down into square roots. If you're prime factoring, you're looking for partners. If you are looking for perfect squares, then you're going to write them as the square root of something that's a perfect square and something that's not a perfect square. So like for instance, 125. I happen to know that I can write that as the square root of 25 and the square root of 5n. Because 5 times 25 is 125. I know the square root of 25 is 5. I don't know the square root of 5n, so that gives me my final answer. So that's what we were doing to simplify these. Okay? Same thing with 216. For my perfect square list from the other day, I know that's 36 times 6. And the v. 512, I know that's 256 times 2. 512, I know that's 256 times 2. But this time we have an m on the inside and an m on the outside. 216, k to the 4th, I know that's 36 times 6, so I have a 6k squared, and then a square root of 6. 100, square root of 100 is 10. The square root of v cubed is v. And then the square root of v. Same way we do it for 80. 16 times 5. And the same way we do it for 45, which is 9 times 5. Okay? So today what we're going to be doing is simplifying radical expressions to add, subtract, multiply radical expressions. So you're going to have to be breaking some down. You may be having to do some manipulation. But either way. Okay? So in order to do the product and quotient rules of radicals, the nth root of a and the nth root of b are real numbers such that the nth root of b doesn't equal 0 when using the quotient rule. The quotient rule is the nth root of a times the nth root of b is the nth root of a times b. The quotient rule is that the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. Now, a couple of things I want to point out. The first thing I want to point out is the roots are the same. The roots have to match. If the roots don't match, not much you can do here. Okay, you have to make it so that the roots will match. Okay, so our first example is we have the square root of 7 and the square root of 3. Do the roots match? Yeah, the roots match. They're both square roots, so we can write that as the square root of 7 times 3, which is the square root of 21. So you can combine them like that. Another example, the cubed root of 9 and the cubed root of 3. Well, the roots match. They're both cubed roots. They're both third root. So you can write that as the cubed root of 9 times 3, which is the cubed root of 27. And the cubed root of 27 is 3. And again, so now we have the square root of 2x and the square root of 8x to the third. They both have square roots, so we can multiply them together. 2 times 8 is 16. X times x cubed is x to the 4th. And then when we take the square root of 16 is 4, and the square root of x to the 4th is x squared. So that's how we're going to do for product rules. If we're doing this, you do the same thing. We have the 4th root of 8b to the 5th times the 4th root of 2b to the 11th. 8 times 2 is 16. B to the 5th and b to the 11th is b to the 16. So the fourth root of 16 is 2, and the fourth root of b to the 16 is b to the fourth. And you're done. Now if we're dividing, we have the fourth root of y to the 12th divided by 11. Well, I can write that as the fourth root of y to the 12th divided by the fourth root of 81. So the fourth root of y to the 12th is y to the third, and the fourth root of 81 is 3. Same thing when we have the cubed root of x divided by 125. We can break that down into two radicals being divided. The cubed root of x divided by the cubed root of 125. I don't know what the cubed root of x is, so it stays the cubed root of x. The cubed root of 125 is 5. So there's our final answer. Now, it's often helpful to have this table. Now, we kind of did this table on our drill paper the other day in class, but it may be helpful to have this someplace where you can keep it easily accessible until you're familiar with them 100%. Remember, if you don't have this accessible, you can always go to your calculator and make it accessible by putting x to the second in y1, x to the third in y2, x to the fourth in y3, and then you've got all of these powers. You could even do x to the fifth or x to the sixth if you wanted. Now, to simplify our radical expression, we are going to use the nth roots and then find the product. So you'll see here we have the square root of 8. We broke that into the square root of 4 times 2. The square root of 4 is 2, so we had 2 square roots of 2. If we have the cubed root of x to the 14th, well, multiples of 3, 3, 6, 9, 12, so we have 3 to the 12th, and, x to the 12th and x to the 2nd, because 12 plus 2 is 14. So that's how we end up with x to the 4th and the cubed root of x squared. So if we're looking for the square root of 20, well, what's a perfect square that divides into 20? 4. So the square root of 20 is really the square root of 4 times 5. Right? So, I lost my pen. Okay, there it is. So the square root of 4 times 5. Well, what's the square root of 4? Well, the square root of 4 is 2, and then we've got the square root of 5. 75, what's a perfect square that goes into 75? Well, it's 25. So 25 times 3 gives us 75. So the square root of 25 is 5, and then we still have a square root of 3. Then we have the square root of 8x to the 5th. Well, the square root of 8, perfect square that goes in, is 4 and 2. And then we have x to the 5th, which I've taken to just writing out 5 times, because that's what x to the 5th means. Right? So, what's the square root of 4? Well, the square root of 4 is 2. I don't know the square root of 2, so that stays in the square root symbol. And then since this is square roots, I'm looking for pairs. So there's one pair of x's. There's a second pair of x's, so that's x times x, which is x squared. And I have an x left over. So I've got 2x times the square root of 2x. Notice how we did that. We're looking for pairs. So the other thing you could have done is, okay, I know that 4 is really 2 times 2, right? And then you have a pair of 2's on the outside, and then the lonely one remains in. So then we have the square root of 32 x to the 7th and y to the 9th. Well, 32 is 16 and 2. Right? And then x to the 7th, I'm going to have x to the 7th, which is going to give me an x to the 6th and an x. y to the 9th is going to give me y to the 8th and a y, because 6 plus 1 is 7, 8 plus 1 is 9. So the square root of 16 is 4, x to the 3rd, and y to the 4th. I need to erase that. Y to the 4th, and then what's left in our square root symbol were the 2, the x, and the y. So now we're looking for cube roots of 40. Alright, so I'm looking at perfect cubes. Perfect cubes were 8 and 5. The cube root of 8 times the cube root of 5 is 2. I don't know the cube root of 5, so that stays as the cube root of 5. 54 is 27 times 2. Cube root of 27 is 3. The cube root of 2 is an ugly decimal, so it stays the cube root of 2. Okay, so we have the cube root of 216. Cube root of 216 is 6. And then the cube root of x to the 16th, well, 16 divided by 3, that's going to be x to the 15th. And x to the 1st, right? So 216 is going to be x to the 5th. And then a cube root of x. So you're going to have 6 x to the 5th and a cube root of x. Okay? Then we're looking at the cube root of 250. Well, that's 125 times 2. The cube root of 125 is 5. So 3, 6, so I've got an x to the 6th, and I've got an x. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Hey, that is a multiple of 3, so I can leave that there. So the cube root of 125 is 5. X to the 6th would be x squared. Y to the 30th would be y to the 10th. And then we've got the cube root of 2x left over. Okay? Now, to add and subtract radicals, like radicals have the same root and the same radicand. So they have to be identical. Like radicals can be added or subtracting by combining the coefficients. So you basically treat the radicals just like terms. In some instances, unlike radicals can be combined first, simplifying, and then the radicands could be the same. So if it says to add or subtract these, well, we're only going to add the ones that are alike. So we've got a square root of 2 and a square root of 2, so those will go together. And we've got a 4th root of 5 and a 4th root of 5, so those would go together. 7 square roots of 2 plus 1 square roots of 2 is 8 square roots of 2. And the 4th root of 5 plus 14 4th roots of 5 is 15 4th roots of 5. So we would have 8 square roots of 5, or sorry, 8 square roots of 2 plus 15 4th roots of 5. Over here, cube roots of 5 go together, so that's 7 minus 8, which is a negative 1. You don't have to write the 1 if you want. I find that writing the 1 helps me make sure that it's not considered part of the radical. Then we've got a negative 10 fourth roots of 5 and a negative 14 fourth roots of 5, which is a negative 24 fourth roots of 5. So we're going to add or subtract. Now, the radicals don't match here, right? But we can make them match because the square root of 18 is really the square root of 9 and the square root of 2. So that means we have 5 square roots of 2 plus 3 times 2, which is 6 square roots of 2. So our final answer is 11 square roots of 2. Yay? Okay, looking at the next one, we have 7 and the square root of 20. Well, we can break down the square root of 20 because it's the square root of 4 times 5. The square root of 4 is 2. 2 times 7 is 14, so we have 14 square roots of 5. Then we have the 6 times the square root of 45, which we can break down 45 because that's really 9 times the square root of 5. The square root of 9 is 3. 3 times 6 is 18 square roots of 5. And then we have still our 5 square roots of 5. So even it didn't look like we could add these together, by simplifying the radicals we were able to. So we have 14 plus 18, which is 32, plus 5, which is 37 square roots of 5. To subtract, you do the same thing. Okay, so square root of 27 breaks into 9 and 3. The square root of 9 is 3, so we've got 12 square roots of 3. Minus the square root of 12 is the square root of 4 and the square root of 3. The square root of 4 is 2. 2 times 8 is 16. 16 square roots of 3. So our final answer is a negative 4 square roots of 3. The next one, this 32 is the square root of 16 and the square root of 2, so that's 4 times 3, which is 12 square roots of 2. The square root of 18 is 9 times 2. The square root of 9 is 3. 3 times 2 is 6, so we've got a negative 6 square roots of 2. And 128 is 64 times 2, so that's 8 times 6, which is 48 square roots of 2. So we have 12 minus 6, which is 6, and 6 minus 48, which is a negative 42. Now, when you're multiplying, you just multiply. Okay, so if we're going to multiply this, we're going to take 2 square roots of 5 times the square root of 3. So when we do that, we get 2 square roots of 15. They had the same root, so we can just multiply. Then we're going to multiply 2 square roots of 5 times negative 6, which is going to be negative 12 square roots of 5. And you look to see if you can combine these at all, and you can't. So do the same thing again. So we have 4 square roots of 3 times the square root of 6, which is 4 square roots of 18 minus 4 square roots of 9. Square root of 9 is 3, so 3 times 4 is 12, so we've got a negative 12 here. The square root of 18 is the square root of 9 times 2. The square root of 9 is 3, so this is 12 minus the square root of 3. So you do want to simplify it as much as you can. Okay, so if we're multiplying binomials, we still do the same thing. We're going to FOIL. So the square root of 2 times the square root of 7 is the square root of 14. The square root of 2 times the negative square root of 5 is the negative square root of 10. The square root of 3, which is negative, times the square root of 7 is negative square root of 21. And negative square root of 3 times negative square root of 5 is positive square root of 15. Do any of those contain perfect squares? No, because this factors into 2 and 7, that factors into 2 and 5, that factors into 3 and 7, that factors into 3 and 5. That's our answer. Here, we're going to multiply again. FOIL again. So we've got the square root of x times the square root of x, which is the square root of x squared. So then we have the square root of x times positive square root of 5, which is the positive square root of 5x. So then we've got negative square root of 5 times x is negative square root of 5x. And then we've got the square root of 5 times the square root of 5, which is the square root of 25, and positive times negative is negative. So when we multiply this together, the square root of x squared is x. Negative 5x and positive 5x cancel out, minus the square root of 25, which is 5. And if it says the square root of 2 minus x, and that's all squared, that just means, like it did before, you're going to write it twice. The square root of 2 minus x times the square root of 2 minus x. And FOIL. So the square root of 2 times the square root of 2 is the square root of 4. Minus x square roots of 2 minus x square roots of 2 plus x squared. So when we combine like terms, the square root of 4 is 2 minus 2x square roots of 2 plus x squared. And then the same thing for the next one. Write it twice. So we have 3 square roots of 5 plus 4 square roots of 2, and we're going to multiply that by itself. Three square roots of 5 times 3 square roots of 5 is 9 square root of 25. 3 square roots of 5 times 4 square roots of 2 is 12 square roots of 10. 3 square roots of 5 times 4 square roots of 2 is 12 square roots of 10. And 4 square roots of 2 plus 4 square roots times 4 square roots of 2 is 16 square roots of 4. Well, the square root of 25 is 5. 5 times 9 is 45. 12 square roots of 10 and 12 square roots of 10 is 24 square roots of 10. And the square root of 4 is 2, and 2 times 16 is 32. So when we combine like terms, we got a 77 plus 24 square roots of 10. And now you're going to do some practice. Thanks for watching.